Hey there everyone, I am thrilled to have you join me today as we dive into the fascinating world of sorting algorithms. Imagine having the power of effortlessly organizing the data and optimize processes. That exactly what sorting algorithms bring to the table. Today we are unraveling the secrets of one such algorithm, and it all starts with our title Mastering Sorting Algorithms by Bubble Sort. Now, let's talk about bubble sort. It's not just any algorithm, it's intuitive, simple, and a fantastic entry point to the world of sorting. Picture this iteratively comparing neighboring elements, swapping them until everything falls into place. It's like tidying up your room, but for data. And the best part is its simplicity sets the stage for more complex algorithms. So, why are we happy today? I want to make sure you are in on the one excitement. Our journey is all about understanding bubble sort, its principles, applications, and how it holds up against other algorithms. You can expect a deep dive into the very fabric of sorting. Buckle up for a hands on experience where you won't just watch, you'll actively participate, turning theoretical knowledge into practical skills.
Hello everyone, I am Sharuk and I am thrilled to guide you through the abstract of our sorting exploration. Let's take a moment to understand the essence of what we are about to unravel with bubble sort. Abstract. As we dive into the abstract, we are peeling back the layers of bubble sort. This seemingly simple algorithm is, in fact, the fundamental building blocks of sorting concept. Think of it the ABC before dwelling into complex language structures. In the next segment, we will establish the groundwork for our sorting journey. Now, let's eliminate the key points. In the upcoming segment, we are not just exploring lines of code, we are dwelling into the essence of bubble sort. We will discuss about how it operates, why it's crucial in the world of data sorting, and why it serves as an essential sorting point for anyone venturing into the realms of algorithm. And here's where gets interesting. We are about to dive into comparative analysis. It's not just about bubble sort. It's about understanding how it stacks up against the heavyweights of sorting algorithms. How does it fare against the quicks and mergers of the algorithmic world? Stick around because that's what coming up next. Requirements using Thinker in Python. The application should have a user-friendly interface to input a list of elements that need to be sorted. Accept input from user, allowing them to enter a list of elements to be sorted. Validate the input to ensure it contains only numeric values. Sort algorithm in Python to sort the provided list. Display each step of the process on the interface for educational purpose. Provide feedback to the user about the progress of the sorting process. Example, swapping elements, sorting in progress, sorting complete. Allow users to clear the input and output fields of a new sorting session. Provide clear documentation for users on how to interact with the application. Include information on the bubble sort algorithm and its implementation within the application.
Hello everyone, I'm Navaaz and I'm thrilled to guide interested challenges and that our Explorable Sort aims to address. Let's get right into it. Problem statement. As we venture into the heart of we are settling our sights on the problem bubble sort sets solve. What are real world scenarios where bubble sort shines and what questions for us as a developers? In the next few moments, navigate through the landscape of sorting challenges and unveil why bubble sorting is a key player. We will talk about the efficiency and limitations now. Now, let's shine a light on the efficiencies and limitations. We are not just scratching the surface, we are going deep. Understanding how efficiently bubble sort operates and where it might face limitations is like uncovering the algorithm personally. Is it swift and agile, or does it struggle under certain conditions? These are the questions we are tackling to grasp the essence of bubble sort in the ground of sorting algorithm. We will do a comparative analysis on this topic, and here's where it gets fascinating on comparative analysis. Picture this bubble sort stepping onto the stage where with other sorting heavyweights, the quicks, the merge, and perhaps new underdogs. How does bubble sort holds up against these contents? That's the question we're exploring in the upcoming segments. For example, there are five elements in the array. The the first and the second will be compared. The second and the third will be compared. The third and the fourth will be compared, and the fourth and the fifth will be compared. The number which is the less will be pushed, and this will happen until the order is in ascending order. Till then, the pushing part will continue to do.
Thank you, Navaz. I'll start from there. So here, I'm thrilled to take you through the hands-on part of journey. Let's get ready for the coding demonstration. So I'll share my screen. You'll be able to see the code running. So here, this is the code for our bubble sort. Here we'll be using for loops in order to check the first element to the next element as Navas previously concluded. This, we declare functions to make it more readable and scalable. So the first one is a function for the bubble sort. This is the main function to run the program. So now we write another function to print the array. Instead of writing them in the main function, we just call it. This is the main function where we're dynamically allocating memory for the number of elements present, whatever the user gives. So if the array is null, memory location does not happen. So you cannot give elements as 0. So using this, we can find the array in the bubble sorting order. So see here, and let's say we have 6 elements. So I'll demonstrate the code and explain the code snippets. So first we import the necessary header files, and then we use functions, and then we call them in the main such so that it's easier for the person to read and it is scalable easily. So this function is the main sorting function. We use for loops in order to check the first element to the next element. Let's say there are 5 elements. It will check from 1 to 2, 1 and 2, 2 and 3, 3 and 4, 4 and 5. This will keep on going until the first one is lesser than the second one, as Navas stated before. This function is to print repetitions and each count of the repetition, and we call them in the main function. So as I run it, take the size of the array. So here I start doing the code demonstration. We use these two header files to. So I'll demonstrate the code. First, we give the required header files, and then we write functions for each so that we can call them in the main. Here, we use a function called bubble sort. We define the function before we use it in the main. So here we use 2 for loops to swap the elements. First element, if greater than next element, it will be swapped. This is for swapping. We use it using declaring them to the temp and doing it. This is to print array to find the number of repetitions and then to print the sorted array. This is the main function where we dynamically allocate memory for the size of array. And then if we'll check if the memory allocation is successful. If not, we'll print to the user that it failed. And then we run the code. So see here, the array with repetition information. 1, it's to 2 repetition. Number 6 is repeated once. Number 12 is repetition 2. Number 34 is repetition 1. So see here, it is already sorted. 1, 6, 12, 4. So it is sorted, and it also tells us the number of repetitions so that we can remove them if we want to. So this will be applied using Python and the Tinker. We use Tinker's library. Before we get into the nitty-gritty of the algorithm, let's talk about something the stage in the upcoming segment will explore, the initial setup of a Tinker GUI. It's just not for sorting, it's about creating an interactive and engaging user interface life to the algorithm. So this is the core of sorting, and it is used in many places. Let's say for sorting the marks, for sorting the salary in companies, for sorting the expenses. As we wrap up this coding journey, I hope you have enjoyed witnessing the power of bubble sort in action. This is not about just sorting data. It's about understanding the intricate dance of algorithms. So we've seen the code now. I'll tell you the real-time applications of these. It can be used in data analysis, where bubble sorting is used to analyze a large number of data sets. It can be used in financial systems to hand the expenses and track the records. It can be used in sorting networks to find which network has the most usage. So as we wrap up this coding journey, I hope you have enjoyed witnessing the power of bubble sort. It's about understanding the intricate dance of algorithms. Thanks for joining me, and also remember this is just the beginning of sorting. There are a lot of sortings. like merge sorts and quick sorts. Thank you.